So let's go ahead and talk about enthalpies of formation. So this is an application of Hess's law. We've already talked about Hess's law stating that the enthalpy changes for an overall process is equal to the sum of the enthalpy changes along the way of each step. Okay. So now what we're going to do is we're going to take this another step and look at the enthalpy of formation. Okay. So the enthalpy of formation is defined as the change in enthalpy to form a substance, in this case ammonia as a gas, from its constituent elements in their elemental state. Okay, their naturally occurring elemental state. So let's go ahead and look at what that looks like for ammonia here. Okay, so we would say the enthalpy of formation of ammonia is negative 46.19 kilojoules per mole. Now that means that's the enthalpy change for a specific reaction. So that's forming 1 mole of ammonia as a gas from its elements in their naturally occurring elemental state. So in this case, it's nitrogen and hydrogen. So what would the naturally occurring elemental state of nitrogen be? Well, it would be nitrogen gas. And for hydrogen, it would be hydrogen gas. Okay. So now again, this is per mole. Okay, so this is for 1 mole of ammonia. So now we want to go ahead and balance this out. And so we'd say, well, 1 mole ammonia, that would mean we would need a half a mole of nitrogen and 3/2 mole of hydrogen. This is the enthalpy of formation reaction. So we're forming 1 mole of the specific substance that we're looking at from its elements in their pure, neutral, naturally occurring states. Okay, so nitrogen gas, N2, hydrogen gas, H2, forming 1 mole of that compound, NH3. The change in enthalpy for this reaction is equal to what we would define as the enthalpy of formation. So this is a formation reaction, so this enthalpy change is equal to the enthalpy of formation for ammonia as a gas. Okay, so now we see that the reason why we're going to use this is because it helps us create a table of a bunch of enthalpies of formations of different compounds that we can then use to identify the enthalpy changes for reactions without actually having to complete that reaction. Okay, so let me note a few things about this. Okay, number 1, see these pure substances? Those are our sea level. That's our base point. So the enthalpy of formation of any of these pure elements, so something like N2 gas, or the enthalpy of formation of H2 gas, or the enthalpy of formation of solid carbon, okay, or solid copper, would be equal to 0. Okay, so that's our sea level, our baseline. Okay, from these changes now, okay, now we're looking at changes again. Then we were to react these, the change in enthalpy that we were to measure would be the enthalpy of formation for, in this case, ammonia. Okay, so if we look at this, we see enthalpies of formation deal with the formation reaction of that specific compound from its elements in their naturally occurring state. Okay, and remember, real important here, it's only forming 1 mole. Okay, so we wouldn't make these whole numbers by making that 2. It's no longer the formation reaction, because the formation reaction forms 1 mole of that constituent substance. So in a later video, we're going to look at how do we apply the enthalpies of formation to actually determine the enthalpy of a reaction. So we're going to look at how do we get the enthalpy of a reaction from the given enthalpies of formation. So that's our next step in our next video.